All right, in the last video we left off kind of talking about some definitions that were key to understanding debt and equity and different ways of adjusting our numbers to really represent um, kind of the bigger picture of how the capital budgeting process in a company works. And we're going to continue down that line. Again, I remind you that if this is feeling really kind of a little bit of everything, a little odd, it's totally normal. We're really kind of just, it's a very, very quick overview of stuff that you can really spend a lot of time studying. And that's really the focus of what you would be seeing in a class such as Advanced Engineering Economics. So anyway, let's continue. The weighted average cost of capital, which is WACC, represents the average cost of all funds available to the firm. Okay, so there's this fancy equation here where, let's see, that thing, what is the name of that thing? I forgot. The little symbol. I'm blanking out for some reason. But anyway, whatever. This variable, it indicates the fraction of capital from debt. Then clearly whatever is not capital from debt is capital from equity. So 1 minus that. T in this equation is going to be the effective income tax rate as a decimal. That I sub B, we spoke about it in the past video. It's the cost of debt financing, and E sub A is the cost of equity financing. Now, I want to remind you, though, that this is a weighted average, and you know how a weighted average works. We've done them before, right? So a weighted average is, in a way, can be as simple as what we do for your grades. For instance, homework is 30%, and your tests are 20% or whatever. So you can take all of those numbers and multiply them by their weight and get a number out of 100 that means something. Now, the only reason I'm telling you this is because I think, and I think I specifically am thinking about an example you might have for homework or in your test that doesn't really quite fit this exact formula. It is just a weighted average. Now, in this case, it's really easy to overcomplicate it and want to fit like, oh, where in my numbers am I getting EA, and where in my numbers am I getting IB, where in my numbers am I getting this and that. Don't overthink it. Just really try to understand what a weighted average is in general, and then what these numbers you need to have as a part of this weighted average, the ones that are needed, how are they provided to you? Do you need to calculate it? You know, you have an equation for EA itself. So you might need to calculate this first, etc. All right. Do not stress. Here we have a simple example. In the first fiscal quarter of 2009, Dell Computer showed total debt of 1.98 million and a total equity of 3.55 million. Assume Dell's beta is 2.2, the cost of debt is 7%, and Dell's effective income tax rate is 35% or 0.35. What is the WACC? What is the weighted average? Sorry, I went the wrong way. Cost of capital. Okay, so pretty simple. Here we can calculate this. My symbol here. I can find, and here I was given this ratio. Now, a lot of times you'll be given that number straight up, but if you don't, this is how you calculate it. Basically, it's debt over debt plus, so the total debt over the total, if you think about that. And this is a percentage, right? So that's why your equation also has this, and it has 1 minus that. So it all depends on what you're multiplying it times. IB here is this 0.06, which this 0.06 is coming from, where is it coming from? I just realized that it should be 7. Yeah, sorry. So this is clearly a mistake. I was like, this is from here, cost of debt. Yeah, remember from this that this was the cost of debt financing. So yeah, that's just a typo. I apologize. In the actual equation, it's not a typo. It's right here. Okay. Then EA, here you have all the components for it, so you can calculate it. You get that it's 0.02, I mean 0.2, and we have this 35% tax rate. So here we had a weighted average by being 0.36, which is this times 1 minus my tax rate times this 0.07 plus 0.64, which comes from 1 minus 0.36 times that 0.02 that we calculated, and this gives me 0.14. And again, right now we don't have to worry about what that means for us, but we do have to understand that there is information that is important to see as more of a global picture. So each company may have an optimal mix of debt and equity, minimizing the Wacc. So again, it depends on the company, and while you may be on that side of the company, or you might be in the side where the people that know this information then tell you how much money you have to spend. One task of a company treasurer is to identify and maintain this mix. A constant debt equity mix is difficult to maintain over time. However, the separation principle specifies that the investment decisions or project selection and financing decisions should be separated, which is actually really interesting because you would think they go hand in hand, and they do, but they don't. Now, we spoke a long time ago about the MAR and how we were gonna determine it, but we mostly talked about what components help make it up. So we'll talk about that a little more, especially pertaining to risk. If risks are roughly normal, the Wacc is an appropriate hurdle rate, so it can be used as a MAR. So the WAP is WAP. Sorry, the Wacc is sort of like the floor on the MAR. So it's the bottom. It should be increased to reflect more risk. So, and we did say that a long time ago. As things get riskier, you want to increase your MAR. Management may choose to set the MAR based on many factors. Such as, for instance, conserving capital and in anticipation for larger future opportunities, or to encourage new ventures or new projects. This may also be differential across divisions. So again, very complicated, very interesting. Then I don't know, I don't know. I do know. I hope that you remember opportunity cost from our first chapter as one of the definitions. With opportunity cost, we see that there's always a trade-off, right? So if I decide to go on vacation and my opportunity cost is the money that I could have, let's say that I'm not making money for some reason. I work per hour. So by going on vacation, I am foregoing that salary that I could have made. So that's an opportunity cost, right? So in this chapter, we focus on independent projects. And unfortunately, you can't choose all of them. When you choose one, you're clearly choosing to not undertake another project. The opportunity cost viewpoint is a direct result of capital rationing when limited funds are available for competing proposals. Prospective projects of similar risk are ranked in order of profitability. The cutoff point it needs to be fall such that the capital is used on the better and more profitable projects. Well, that's obvious. And this is a lot of what we've seen in this class. And I guess this is the part where you might be like, oh, I see now where this kind of all makes sense. Firms may set 2 or more MAR levels, analyzing with particular risk categories. So it's not fair to compare a very risky project to a very low risk project, because the high risk project might look so much more profitable, but then, it's also riskier, duh. All right. So here's where capital budgeting comes in. I want to spend some time on this graph. So here in this graph, we have these rectangles, and each rectangle represents a different independent project. Now, some of these rectangles are thicker in this direction because that means they're more expensive. For instance, this particular project right here, if this is the investment amount, it seems like this one is a little over $1 million. Whereas this skinny little thing right here, this one's probably like, $100,000 or something, right? And while this right here is the prospective internal rate of return based on estimates. It says prospective because, it's estimates from the future. So how do I decide what projects I can afford? Let's say that I have $5 million, right? No, let's say we have $4 million. How many projects, or which projects can I fit? There should be a line right here. Within $4 million, where it makes the most sense, especially where I'm considering that all of these have similar risk, that I want the best projects are the cheaper that give me the most, well, not necessarily, right? Because they'll bring less money, but I want, in terms of internal rate of return, and remember, with internal rate of return, it's tricky because it really only makes sense if you comparing internal rates of return themselves doesn't necessarily mean that this project's better than this one or better than that one, but it does mean, after you set your this line right here, this line is your new set MAR. That just means that all of these are acceptable projects. So don't get confused. This is not a ranking of best project to worst project. It just means, okay, so if I have a certain amount of money, like $4 million, or if other factors made me choose, let's say that I'm selecting a MAR of 20%, then I can line up all of my projects and choose to only spend my money on the ones that are over 20% internal rate of return. Okay, so then once I do that, then I can figure out the present worth of each of these projects or some other measurement of worth, of equivalence, and then select which ones I'm actually going to fund. Let's say that I used this number right here based on what I had, but in reality, maybe I could only spend 3 million. So now how do I choose between these? If I only have 3 million, well, I can't afford this one, but clearly I need to kind of figure out a different way of measuring these. Present worth would be a good way. And try to squeeze as much money out of this optimizing. And it becomes a linear programming model in a way, which is beyond the scope of this class. So budgeting for capital investments is a difficult managerial challenge. Just because a project's attractive doesn't mean it should be undertaken. Capital budgets, while perhaps with a 1 or 2 year horizon, should be supplemented with a long-range capital plan. Also, technological and market forces change rapidly nowadays, so something that is perfect and awesome and amazing and exciting today can be a terrible idea tomorrow. Decisions must be made regarding investing now or saving some funds to invest in the future, even if that means postponing returns. Let's see here a brief example. If we have a budget of $150,000, which of the following independent projects should Mistelfic Inc. invest in? So we have 4 independent projects worth, the initial capital outlay is given here, and their present worth at a particular point in time, let's say that they're all compared fairly, right, is this much. So now let's put some sort of, well, we have this cap. So sadly, we can't afford all of them. So if we add this up, let's see, 70 plus 40, 110 plus 50, 160. This is like 200. This is like 205, right? Forgive me if I did that wrong. I did it really quickly in my head. The point is we can't afford them all. How do I choose which ones? So this is where our good friend Excel or some sort of spreadsheet software comes in because it's annoying to do by hand. But basically you want to find the total present worth or whatever equivalence measure you're using and find how to optimize this. Now this is a very, very simplified version. There's more efficient and more like sturdier versions of this that involve really getting into the linear programming aspect of this, which we're not going to do. This is a very simple example. So then I start combining. So let's see. AB 115, AC 110. So I'm just trying to stay, these all need to be under 150,000. Now here we see BCD, and you notice that I am missing the combinations ABC, ABD, and let's see, BC, ABC, BCD. I think that's it, right? I'm missing one. Which one? ABC, ABD, BCD, ACD, and ACD. All of these combinations go over 150, which is why they're not mentioned here. Okay, and then I can see the total present worth of these projects and find the one that maximizes my profit and say, well, I'm going to forego A, even though A is a perfectly good project. Actually, if you compare present worth, AB gives me a higher present worth than either one of these individually. But as it turns out, if I leave that one, it also happens to be the most expensive one. So if I do these 3, it's better than just doing A with another one. Nothing really gets, the one that gets closer would be AD. But no, we can afford BCD, so let's go for that. So, oh, and I also forgot ABCD. Well, clearly that wasn't an option from the beginning. So management also always has to decide how to best to allocate or not allocate the remaining 15,000. So there's extra money here, and that it's really hard for projects to add up to the exact right amount. Although usually things go over and then people find a way to make them cheaper, but that's neither here nor there. Okay, other important managerial considerations and complications. For instance, projects have different lives and different cash flow commitments. Projects having different levels of risk. The long-term capital plan must be considered. The overall risk of the firm must be considered. The corporate strategy plan may favor one part of the company over another for investment. Much, much more. And we can talk about this forever. And we've sort of mentioned some of the complications in the past, but we have And a lot of the complications even come from just estimates, right? So we're assuming our estimates are great, but things change so fast, our economy changes so fast, and the global market is very volatile. So in any case, um, this is where I want to leave you. This video has gotten a little longer than I wanted it to, but in any case, um, I hope that you kind of have that you're seeing where this is headed, how big and complicated this can get. But of course, as engineers, our biggest role will be just to understand the economic implications have a huge role in decision making, and that we have to be aware of that. Otherwise, we'll end up designing stuff that nobody can make or nobody can buy. In any case, I hope you got a lot out of this, and let me know if you have any questions. If you want to know a little more about this, that chapter in the book does go a little deeper into this, but it does mention several times like this is outside the scope of this class. So again, if this is something you're fascinated by, then I highly recommend taking sort of like advanced engineering economics. All right, well, that's it. Bye.